that I want to sort of run very quickly, given the 5 minutes here. I'll try and cover at least most of the important parts of that. The first thing that I'd like to just start off with is, Mark Andreessen said a while ago that software was eating the world. What he meant by that was that most of the automation, most of the logic, most of the hard work that goes into determining how a machine can act intelligently, that was being taken away from the hardware design guys and was now being applied in the world of software and was being expressed as software. So you could have simple mechanical constructs. Take an electric car, for example. It's mechanically simpler than a traditional car, but yet it has so much more functionality because the complexity has migrated to software. AI is eating software. That's my adaptation of that phrase. But that's to say that this new way of thinking about building intelligent systems, this has arrived, it works, and it is truly changing the nature by which software is constructed. So now, for the purposes of our discussion here, this has many, many implications. Well, the first implication is the world is changing. If you look around, there are middling powers that are vying for the kind of attention perhaps that they haven't received historically. Cyber war is a real thing. And our infrastructure, including our oil and gas infrastructure, is no longer just a means of production. It's also looked upon by others as part of our target set, as part of the set of systems that they would look to recce, that they would look to log, and that would be on target lists. I work quite often with the Pentagon and had the privilege of briefing the Senate Armed Services Committee twice over the last year. If you look at the public domain, all these citations that I show you on the slide, these are all real things that have happened, and the rate at which they're happening and the scale at which they're happening is large. So going in, there's two big problems. One is natural failure. We all know about this. Bearings failed, equipment falters, environmental conditions, maintenance conditions can cause all sorts of problems, but then there's also the malevolent threat, and this can no longer be ignored. Now, putting all of this together, one of the other things to really understand is that there is an absolutely unstoppable move that the world collectively is taking towards making more of the world measurable and more of the world actuated through software. So it's not just about telling you what the temperature is, it's also perform an action when the temperature hits a certain spot. And so much of this automation is now happening that there are emergent phenomena that are coming up. Levels of complexity from the interactions of M2M systems that we have directly not designed. And in this world, trying to apply traditional security methodologies, for example, is really a losing proposition because of scale, because of speed, because of complexity, because of the really massive number of false positives that show up when you apply statistics techniques. So within the oil and gas community, there are many points that are vulnerable, both for natural failure, which this audience understands very well as for cyber attack. And most of the community actually agrees. So this is actually a set of surveys that shows, for example, that 66% of the polled audience believe that their organizations are benefiting from digitization, but the benefit has arrived with increased cyber costs. That's the almost 2/3 holding that view. So without going into all of this and parsing for you each one of these points of feedback, the thing is very simple. Cyber physical safety and security is now a thing. It is one thing. It cannot be atomicized any further. If you're going to put assets online, if you're going to measure assets, if you're going to actuate assets, if you're going to put more smart software to actuate these assets, then these assets develop a cyber and a physical reality. The components of every asset become cyber and physical. So cyber and physical safety and security is really something to focus on. And my submission here to you today is that doing this at the scale that we know we'll have to solve this problem at. For example, if you look at Cisco's estimates of IoT devices, 50 billion by the year 2020, there are many others that corroborate that kind of number, that kind of growth. Certainly, human analysts won't be able to do that. Earlier, we were having the discussion about augmentation and the use of AI technologies to take the few human experts that we do have for the current infrastructure. But what about the 7-fold increase in that infrastructure that we're expecting soon? What about the maintenance professionals of the utility community who could take retirement today? And if they did, we wouldn't have much of a maintenance crew left anymore. So our solutions to some of these things, work that we've done over the years, is in the area of automated model building. The idea is not to apply machine learning to solve a problem. The idea is to apply meta-algorithms to build the mind of a data scientist and then build the model. So this is a very long topic, obviously. It involves fusion of genetic algorithms, of neural evolution, of deep learning, of reinforcement learning in cases where we have to adjust action and not just perceive things, which we can come to later. But the important thing is that over just about 3 years of testing this technology, some very large operators have found great results. For example, Flowserve has been able to apply automated model building and extend their failure forewarning from 4 hours to 5 days. And you can see the rest here. Now, in oil and gas also, we're looking at applying these techniques for a variety of different scenarios. When it comes to rigs and wells, optimization, identifying kicks, finding, again, optimization and production solutions, building the mind of a production analyst, if you will, adding value to artificial lift systems. These are all things that we are doing today with automated model building technology, which we think is tremendous and has a great promise because it truly augments the data scientist and doesn't just require more data scientists to build more models.